Assalamu alaikum. I am Aijaz Ahmad, physics teacher working in education department, presently posted at Boys Higher Secondary School, Warsun. As all of us are aware about the pandemic situations of COVID-19, teachers all over the world are trying to educate the students through by online or offline classes. Our worthy director School Education Kashmir has already issued an order regarding the same practices. Now, I being a physics teacher, my worthy principal ordered me to give few lectures on the same subject. Now, I will start on the same topic which I had already started in my school. So, the topic that is a dimensional analysis. So the next part of that topic, which I had already started in the school, that is a uses of a dimensional analysis. Now, as far as class 11th is concerned, dimensional analysis can be used in three different ways. Number one, we can convert one system of unit into another system of unit. Means we can convert SI system into a CGS system. We can convert a CGS system into SI system. Number second, we can check the correctness of the physical relation. We can check whether the given physical relation that is dimensionally correct or incorrect. Similarly, number third, we can derive the relationship among the various physical quantities which are involved in the dimension or relation. Now we will discuss one by one. We will derive the formulas one by one. First of all, we will derive the expression for the conversion of one system of unit into another system. So in the previous lectures, we have learned about the basics of the dimensional analysis. We know about the physical quantity, what's a physical quantity, fundamental units, fundamental quantities, derived quantities, derived units, system of units, 7 fundamental quantities, supplementary units. So we know that a physical quantity can be written in this way. A physical quantity, suppose the physical quantity can be written as x. So that physical quantity can be written in this way: x is equal to nu, where this x that represents a physical quantity such as mass, length, time, force, anything. X represents a physical quantity. Physical quantity. Now we have n, that's the numerical value. The unit n, that's the numerical value. Numerical value. So it's a numerical value. The number of times, numerical value means the number of times the unit is present in this physical quantity. So I will explain it with the help of an example. So U is equal to the unit in which physical quantity is expressed, in which physical quantity is expressed. So we'll take an example here, such as a length of a rod. That is 3 meters. So the length of the rod is a physical quantity. That means this length, that's a physical quantity which we represented by x equal. Now this 3 is a numerical value. That means this meter is present in this physical quantity, that's the length, by 3 times. So we'll write it as n. And m, that is the unit in which the physical quantity is expressed. So that's the unit. So we'll write it as u. So this is the representation of the physical quantity. But we have to convert one system of unit into another system. So we'll write the two systems. So let M1, L1 or T1 be the fundamental units in one system. in one system. One system. So here n1 represents the n1 be the numerical value. Numerical value. That means that the unit, how many times the unit is present in this physical quantity. So we'll write here A, B and C. These are the dimensions of the mass, length and time. If the mass is present in the physical quantity, but how many powers? Length is present in the physical quantity in how many powers? Similarly, if time is present in the physical quantity in how many powers? So A, B and C are the dimensions of mass, length and time. Then this equation, this relation that can be written in this form, x, that's a physical quantity, that is equal to n. N be the numerical value. So in the first system of units, we write it as n1. So this is n1. Here U represents the units. Now here the units are mass, m1, l1, t1. So m1, l1, t1. But mass is present. But how many powers? In how many powers? So we'll write it as A. Here we'll write it as B. It means that length is present in this physical quantity, but in how many powers? So power is here, that is B. So T, time, so it will be C. So this is the first equation in one system of unit. But we have to convert it into another system. Then we will write here M2, L2, T2 be the fundamental units, fundamental units in the second system. And N2 be the numerical value. Similarly, we will write here A, B and C or the dimensions of mass, length and time. Then the expression in the next system of units can be written as x is equal to n2. Here it was n1. Now here it will be n2 into m. Here it was m1. In the next system of unit, we will write it as m2. So raised to power a, l2 raised to power b, t2 raised to power c. So this is equation second. Now we will compare equation first and equation second. From equation first and equation second, we get from equation first and equation second, we have so we'll write here x that will be cancelled to each other. So here n2 that into m2a, l2b, t2c is equal to n1 into m1a, l1b, t1c. So we'll calculate here n2 that is equal to n1 m1a, l1b, t1c whole divided by this m2a, L2 B T2 C, or we can write in this way, N2 that is equal to, so it is N1. Here we see here M1 M2 raised power A raised power A. So we'll write in this way, M1 divided by M2 whole raised to power A. Similarly, L1 divided by L2 whole raised to power B. Here it is T1 T2, so we'll write it as T1 T2 whole raised to power C. So with the help of this formula, with the help of this expression, we can derive one system of unit into another system of unit. So we can convert SI system into CGS system. We can convert a CGS system into SI system. Now in the next video, we will derive the numerical problems which are usually asked in the board exam as well as in the competitive exams. I hope you like this video.